In this video, we will look at the concept of control flow. Recall that control flow refers to the order in which lines of code get executed. The control flow is created by a control structure that orchestrates the execution. There are three fundamental types of control structures: sequence, selection, and iteration. The most basic control structure is the sequence. It is what you have been using up to this point. The selection control structure includes conditional statements. In most languages, a conditional statement will consist of some kind of if-else statement. They allow certain lines of code to be selectively skipped based on certain conditions. The iteration control structure includes various types of looping statements. In most languages, a looping statement will include of some kind of for each statement. They allow certain lines of code to be repeated multiple times. These types of structures can be applied in different ways. Let's look at that next. Previously, we discussed how parametric modeling applications can be categorized based on how they support iteration. The four broad categories are object modeling, associative modeling, dataflow modeling, and procedural modeling. Object modeling does not support any iteration. Associative modeling supports iteration, but with loops that contain a single operation only. Dataflow modeling and procedural modeling supports multi-operation iteration. Dataflow modeling supports implicit multi-operation iteration through structuring of lists of data. Procedural modeling supports explicit multi-operation iteration using looping constructs. Now, we are going to look at how selection and iteration constructs can support implicit iteration. Next week we will look at explicit multi-operation iteration. So next week, you will learn how to use conditional statements and looping statements in your code. Implicit control flow is created by calling functions with data structured in specific ways. This means that you do not need to create the control flow yourself. You can instead just pass the right data to a function, and let the function loop over the data. In order to understand how this works, we will first need to have another look at functions. Specifically, we need to look at the concept of function overloading. Functions can have internal logic that allows them to change their behavior depending on the input arguments. When calling such a function, you can vary the input arguments to achieve different outcomes. This is called overloading the function. There are three ways that functions can be overloaded: Arity, data types, and data structures. With regards to control flow, we are mainly interested in overloading with data types and data structures. But we will briefly describe Arity as well. The first type of function overloading is with Arity. Arity refers to the number of arguments that a function expects to receive. In the example, we look at the function called range. It generates a range of numbers. It can accept either 2 or 3 input arguments. If you give the function 2 arguments, then it will generate a range of numbers with a step size of 1. If you give the function input arguments, then the third argument controls the step size. Internally, we can imagine how the range function works. A conditional statement can be used. The condition will check the number of arguments. If the number of arguments is only 2, then the function sets the step size to the default value of 1. The second type of function overloading is with data types. A function can accept arguments with different data types. In this example, we look at a function called len. The function can be used to get the number of items in a list, or to get the number of characters in a string. Let's imagine how the range function might be implemented internally. A conditional statement can be used. The condition will check the type of the input argument. If the argument is a list, then the function will count the number of items in the list. If the argument is a string, then it will calculate the number of characters in the string. Here is another example. In this example, we look at the make_copy function. It makes copies of entities. The first argument is the entities to copy, and the second is the vector to move them by. The first argument is overloaded. You can either pass in a single entity, or a list of entities. The data types of the first argument can therefore be different. The data type can be a single entity ID or a list of entity IDs. If it is a list, then the function would have to iterate over the entities in the list. Let's look at the next example to see how that might be implemented. Let's look at the third type of overloading. This is the one that is most useful when it comes to implicit control flow. It is overloading with data structures. In this example, we look at the makePosition function. For the data structure, the function will look at how the lists of coordinates are structured. If you pass the function a list of 3 numbers, then it will generate a single position and return that position. If you pass the function a nested list of lists, then it will loop over the outer list. For each sub-list that it finds, it will generate a position. After creating all the positions, the function will return the list of new position it created. Let's again imagine how this might be implemented internally. In this case, the control structure will be a little more complex. At the top level, there can be a conditional statement that checks the data structure. The condition will check the data structure of the input argument. If the data structure is a list of 3 numbers, then the function will generate a single position and return that position. If the data structure is a nested list of lists, then the control flow will move to a looping statement. The looping statement will iterate over the nested list and will generate one position for each sub-list that it finds. When it has finished looping, it will return all the new positions.